Okay, class begin. Last time we have learned section 4.8, the Karnaugh map. So we must know that what is the Karnaugh? What is the definition of Karnaugh? Karnaugh provides a systematic method for simplifying Boolean expressions. The purpose of Karnaugh is to simplify a Boolean expression and will reduce the simplest SOP expression or POS expression. SOP, the full name is sum of product, and the POS, product of sum. But the most popular form is SOP. So we must know how to translate an expression to SOP form. A Karnaugh presents all of the possible values of input variables and the corresponding output. It is similar to the truth table. But the form is different from the truth table. The Karnaugh is an array of cells in which each cell represents a binary value of the input variables. And Karnaugh can be used for expressions with 2, 3, 4, and 5 variables. 2, 3, 4, and 5 variables. If the variables are more than 5, then we cannot use Karnaugh. The Karnaugh can be used only for expressions with 2, 3, 4, and 5. And the number of cells in each Karnaugh is equal to the total number of possible input variable combinations. If there are n variables, then the number of cells is 2n, is 2 power n. Is 2 power n variables, and the number of cells is 2 power n. Right? For example, if there are two variables, then the number of cells is 4. If there are 3 variables, the number of cells is 8. If the number of variables is 4, then the number of cells is 2 power 4, 16. The 3 variable Karnaugh is on a array of 8 cells. We can also use another 4. ABC. But we must to remember that the order of the value is 0, 1, 1, 1, then 1, 0. Because we must make sure that each adjacent cells has only one bit difference. They are safe and they are different. They are safe, they are different. Same, different. Right? And we use the complement of the variable to represent 0 and use variable to represent 1. So 0, 0, 0 is used to represent A bar, B bar, C bar. 1, 1, 1, 1, 1, 1 represent A, B, C, A, B, C. The 4 variable Karnaugh is on a array of 16 cells. 16 cells. Also, we must remember that this is 1, 1, 1, 0, and this also 1, 1, 1, 0. To make sure every cell, every adjacent cell are nearby each other and only have 1 bit difference. Adjacency, cell adjacency. In the Karnaugh, we must to know that the 2 cells are nearby each other, are adjacent, and these 2 cells are also adjacent to each other. And for the 4 variable Karnaugh, each cell has 4 cells next to it. 2 cells. The first cell, the second cell, the third cell, the fourth cell. The 4 cells are adjacent to this cell. And for this cell, there are 1, 2, 3, 4. 4 is this cell. So there are also 4 cells are adjacent to this cell. But the diagonal cells are not adjacent to this cell. If these 2 cells, we know these 2 cells are adjacent to each other, we call this wrap around adjacency. Wrap around adjacency. And a cell is not adjacent to the cell that diagonally touch any of its corners. So the 4 cells are not adjacent to this cell. Are not. Okay, we have known the definition of Karnaugh. Then, how to use Karnaugh simplify on expression. So we must to know that what is the Karnaugh SOP minimization. Both minimized SOP expression contains the fewest possible terms with the fewest possible variables per term. And fewest possible term and the fewest possible variables per term. The method is we must first to know how to map or standard SOP expression. The method is place one on the Karnaugh map for each product term in the standard SOP expression. The first step is determine the binary value of each product term in the standard SOP expression. And the second step is each product term is evaluated, place a 1 on the Karnaugh map in the cell having the same values of the product term. So this example, map the following standard SOP expression on the Karnaugh map. This is on standard SOP expression, so it's very easy. Step one. Determine the binary value of each product. The first product term. The first product term is what? A bar, B bar, C. A bar, B bar, C. What is the binary value of this?
A bar, B bar, C.
Yeah.
001.
Yeah, 001. And A bar, B, C bar.
010.
010.
110.
And A, B, C bar. 110.
111.
A, B, C. 111. Means what is the binary value of this product term?
111.
Yeah. So then step 2, place a 1 on the Karnaugh map if the corresponding binary value is 1. So in the Karnaugh map we know that the value, there are 4 cells. Which value is 1? Right? Which value is 1? The first cell is 001. So 001 is this cell, right? 001. And the second cell is 010. 010. This cell. The third cell is 110. 110. That's it.
This right side.
Yes, it is 1. And the last term, 101, is this cell. So the other cells,
0.
the value, which value is 0? We can write it
0.
with 0, or don't need to write. The second example, map the following standard SOP expression on the Karnaugh map. There are 4 variables, so we must use the 4 variable Karnaugh map. The 4 Karnaugh map has 16 cells. The first step is write down the binary value of each product term.
0011.
0011.
01.
0100.
11.
1101.
01.
1111. 1100. 0001. 1010. And then place 1. Place 1 on the Karnaugh map.
Yes, sir.
Write down the 1, 2, 3, 4, 5, 6, 7. Write down the 7 ones on the corresponding cell. So there are seven ones on the Karnaugh, and the value of the other cells are 0. From this, we only use Karnaugh to represent all expression, Boolean expression, but we have not simplified this Karnaugh. Simplify the expression. We have not. and we just learned the standard SOP expression. How to use Karnaugh represent also standard SOP expression. If the expression is not or standard SOP expression, then the method is different. We must convert the non-standard SOP expression to standard form. For example, AB bar. If there are three variables in the domain, then we must add the third variable. So we must convert AB bar to AB bar C plus C bar, right? We must convert AB bar to AB bar 1 equals to AB bar C plus C bar. So there are two standard product terms, A, B bar, C bar. So the two product terms is 1 0 1 0 0. So we must attach O0 and O1 to the missing variable. For example, map the following SOP expression on the column map A bar, AB bar plus ABC bar. So we know that there are three variables in the domain. So we must convert A bar and AB bar to three variable product terms. Three variable or three literal product terms. So A bar must be converted to AB bar must be converted to AB bar C, AB bar C bar. So there are two standard product terms, 1 0 0 1 0 1, and A bar. There are four standard product terms. A bar. We can write down this B plus B bar and C bar plus C, right? So the boundary value for this term is equal to A bar, B bar, C bar plus A bar, B bar, A bar, B bar, C plus A bar, B C bar plus A bar B C. Right? Right? So there are four terms. Four product terms. There are four product terms. And AB bar. So the binary value is 0 0 0 0 0 1 0 1 0 0 1 1. So there are four product terms. So we must write down this four. Write down the four product terms. So the total number of product terms is 6, right? It's 6. So there are six ones on the Karnaugh. 6 1. Or 7. 1 2 3 4 5 6 7. There are seven ones on the Karnaugh.
1 0.
Yeah. So we know that we can use Karnaugh to represent on SOP expression. SOP expression. And from now on, we will learn how to use Karnaugh. Use Karnaugh to simplify all SOP expression. First, grouping the ones rules. The ones rules. What is the rule? The grouping the ones rules. All group must contain either 1, 2, 4, 8 or 16 cells, which are all powers of 2. So we must group the ones. Use the rules like this. For example, there are 4 ones. How to group them? How to group them? We can all group must contain 2 or 1, 2, 4 or 8, 1, 2, 4, 8 or 16 ones. 16 cells. So the 6 ones can be divided into 2 groups. But we know that the 4 ones are adjacent to each other. So the 4 ones can be divided into 1 group. Can be divided into 1 group. And these two ones can also be divided into 1 group. But we know that these two ones are nearby to this one, these two ones. So the 4 cells are adjacent to each other. So we can we can use a group to contain these 4 ones. So the 4 ones can also be regarded as a group. But the 6 ones cannot be regarded as one group because the numbers must be 1, 2, 4, 8, or 16. Must be the powers of 2. The second rule, each cell in a group must be adjacent to 1 or more cells in the same group. So, in one group, there must be 1 or more cells adjacent to each cell. But all cells in the group do not have to be adjacent to each other. For example, for this group, there are two cells. There are 2 cells adjacent to this cell, right? 2 cells, this cell and this one are adjacent to this cell, right? But these two cells are not adjacent. This cell don't have to be adjacent to this cell. Don't have to be. We only need to make sure that 1 or more cells are adjacent to each cell. Rule C. Always include the largest possible number of ones in the group in accordance with Rule 1. Include the largest possible number. So first, for this Karnaugh, we know that the 4 ones are in the same group, right? In the same group, and these 2 ones are in the same group, right? But we know that these 2 ones are adjacent. So we can divide the 4 ones to one group. Because we must always include the largest possible number of ones. So if there are 4 ones are adjacent to each other, we can divide the 4 ones into one group. Rule D. Each one on the map must be included in at least one group. Each one on the map must be included in at least one group. And the ones already in the group can be included in another group, as long as the overlapping groups include non-common ones. What does this mean? What does this rule mean? For example, for this Karnaugh, how many groups on this Karnaugh? Four. Four groups.
1, 2, 3, 4.
4 ones.
Yeah.
There are 4 ones on the Karnaugh. But how many groups on the Karnaugh?
See?
3. Which 3?
4.
Do you think this is group 1? This is group 2? Group 3?
No.
Which 3 group? Oh, I know. I understand. Do you mean that these 2 ones are in one group?
Yeah.
And these 2 ones are in one group?
Yes.
So there are 3 groups.
And
Oh,
one
I know.
and doesn't.
So the third group is, you think the third group is the 2 ones like this, right?
Yes.
Right? 3 groups. Do you think? Make note this sentence. The ones already in the group can be included in another group as long as the overlapping groups include non-common ones. Non-common ones. So, do you think this group has common one? These 2 groups have common one, right?
Yes.
And this group and this group, these 2 groups also have one common one. So this group don't need to be right. Don't need to be right. So there are only 2 groups. Because the two groups include all ones. The 2 groups have included all ones. Include all ones. Two groups. These 2 groups.
1, 2.
Right?
1.
Understand? So, we don't need to divide these 2 ones into one group. We don't need, because all the ones are contained in each group. So there are 2 groups.
So
For this example, there 1, 2.
If the four ones are nearby, are adjacent to each other,
Yeah.
we must divide them.
One group.
Four groups, the four ones into one group.
This is one group.
Yes, yes. And this one, the four ones are in one group. And the four ones are in one group. So there are three groups.
This one and this is this one.
Yeah.
One group. This two.
Yeah, yeah.
This three.
These three. These two. And one. Understand? Yeah. The two cells are under one. The one is not a cell.
Let's see very close.
Okay? Have a rest for 10 minutes.